Today there's a lot to talk about. First, the date for the Crew Dragon in-flight abort test has been finally set. Then the SLS is being shipped for its first test. In other news, Elon teased a bit on how the Starlink user antennas would actually look and how they would actually function. Then a bit about exoplanets again, because we think exoplanet discoveries are extremely important for us to understand our place in the universe.
Then a highly interesting Earth-sized exoplanet has been discovered in the habitable zone of another star. Then a new improved method has been proposed on how to search for life on other exoplanets with the James Webb Space Telescope. And then a technique has been tested which would allow for interstellar travel with a LightSail. And then another new study which found that Mars is losing water much faster than we initially thought. And you didn't really think that we wouldn't talk about the current progress of Starship, did you? There's really a lot to talk about this week, so stay tuned.
So the date for the very important Crew Dragon in-flight abort test has now been set to the 18th of January. The hardware is of course already at Launchpad 39A at Kennedy Space Center in Florida, and also already underwent test firings. The in-flight abort test will be an uncrewed suborbital flight of a Crew Dragon capsule on a Falcon 9 rocket, which will test the safety abort system, where the Dragon capsule will be jettisoned off the rocket. This is of course extremely important for future crewed flights, because if something should go wrong with the Falcon 9, the capsule needs to be able to land again with astronauts on board unharmed. So if the in-flight abort test will be successful, then SpaceX will be one giant step closer towards sending astronauts to the ISS with Crew Dragon, according to current plans, sometime in the second quarter of this year, much to the dismay of Boeing, of course.
Talking of the devil, the SLS core stage has left the Michoud Assembly Facility in New Orleans just last week and was loaded onto a barge which is headed to NASA Stennis Space Center in Mississippi, where the green run tests will actually start. And as we all know and love NASA, those tests will be very lengthy and be repeated over and over and over and over again, and it will certainly take quite a few months of testing. Now this SLS center core will be the very same one that will fly on the Artemis 1 mission later this year, according to plans, which always can be delayed with SLS, as we know, in order to send an Orion spacecraft into orbit around the moon. Now in 2022 Artemis 2 will follow with the first crewed round trip around the moon, and Artemis 3 will foresee the first crewed landing onto the moon in 2024. But you of course already know what we think of this, right? We somehow feel a bit like Cato. You know, Cato, who after every meeting of the Senate in the late Republican era of ancient Rome proclaimed, "Furthermore, I consider that Carthage must be destroyed." So we really feel that we have to hold ourselves back every time after talking about Artemis, not to conclude the Artemis news with the sentence, "By the way, we think that Starship will land on the moon first."
In other news, Elon teased a bit on how the Starlink user antennas would actually look and how they would actually function. Now we all know that the Starlink satellites, which will by the way at some point in this year be plentiful enough to start coverage for North America, will circle the Earth in heights ranging from 400 to 1,200 kilometers. So they whiz past the ground quite fast and are therefore not stationary in the sky, in contrast to geostationary satellites. So the Starlink antennas or receiver dishes will be self-adjusting. Elon tweeted that the user-friendliness will be extremely high. The antenna basically only has to be plugged in and it will take care of the rest all by itself, automatically tracking the best visible Starlink satellite in the sky, then switching to the next one and so on. The antenna itself will look like a flat-ground UFO on a stick, which sounds quite cool. We can't wait to see the antennas in action, hopefully by the end of 2020, if the aggressive Starlink launch schedule will continue like now, which we think it will. An amazing Starlink year ahead of us.
Now you know that normally we talk much more about the current progress of human spaceflight, particularly with an eye on SpaceX and the colonization of the solar system, especially the Moon and Mars. But we also shouldn't forget the amazing expansion of our knowledge about the universe. And last week some amazing scientific discoveries have been made, particularly regarding exoplanets. Now, the Transiting Exoplanet Survey satellite, also known as TESS, has found an Earth-sized exoplanet in the habitable zone of another star. But what is really amazing about this exoplanet is that it has a similar size and mass to Earth and is therefore a rocky planet with a surface on which one could really stand, so not a gas planet. Now, the planet has been named TOI 700D, which stands for TESS Object of Interest, and is located 101.5 light years away from us, circling a K-type dwarf star. Now, these K-type dwarf stars are a bit smaller, a bit less massive, and a bit dimmer than the Sun, with this particular one having 40% the Sun's mass, and it is only 50% as hot, therefore it's glowing with an orange color to the human eye. Now, TOI 700D, the third planet in this system, is located in the habitable zone, and together with its very similar size to Earth, could be a perfect place to search for life. Now, what is also interesting about K-type red dwarf stars is that they are not as aggressive as N-type dwarfs, because the even dimmer and even less massive M-type dwarf stars have very aggressive flare eruptions in the first few billion years of their lives, sending out an intense shower of radiation, which is of course not very good for the evolution of life. But K-type dwarf stars are much calmer and don't have these aggressive eruptions, so the likelihood of life having a chance to develop on a world circling a K-type dwarf star in the habitable zone is quite high if there would be liquid water present. Now, TOI 700D circles its star once every 37 days and might be tidally locked, which would be a fascinating world with a perpetual day and a perpetual night side. Now, on such a world, we'd see a nice comfortable ring of friendly and moderate climate around the planet, not far from the day-night terminator. Yes, the day-night divide of a planet is actually called a terminator. Skynet would be proud.
In any case, this planet will be a highly interesting target to point the James Webb telescope at in the next years after it will go online in 2021. In order to search for biosignature gases, so gases that arise due to the existence of life. And fittingly, a new study led by a team at UC Riverside suggests an improved method of detecting exoplanetary oxygen. They conducted some transmission spectroscopy simulations for oxygen to non-oxygen atmospheres and looked at collision-induced absorption of oxygen with non-oxygen molecules, which happens when a ray of light from the parent star hits an oxygen molecule in the planet's atmosphere. And this oxygen molecule then in turn collides with another molecule, for example nitrogen, and thus the ray of light from the parent star is absorbed. James Webb Space Telescope would have the necessary sensitivity to discern oxygen planet atmospheres from such planets where oxygen is created by non-biological processes, even for planets that are a lot further away than 10 light years. So this is very good news for us to discover the first world with life, which we think will happen sooner than many expect. Our estimate is that by the end of this decade, we will know a few exoplanets where we can say with very high certainty that they host some form of biological life. But in order to get some high quality footage of such planets, we will need to fly there. And what better method than to shoot a LightSail there with very powerful ground-based lasers? Project Breakthrough Starshot aims to do exactly that. We have talked about it already a few times, for example in this video here. Now a new method has been developed, using a layer of diffraction grating on the solar cell to let the solar cell self-adjust itself while being accelerated with high-energy laser beams. Therefore, we would be able to precisely shoot these probes to interesting destinations in our vicinity at 20% the speed of light. So a trip to Proxima Centauri in about 21.5 years. Then, of course, the transmission back would take another 4.3 years. So we could have pictures of Proxima B 25.8 years after the probe would have been launched. Truly an amazing development of extremely high importance for our interstellar future. Now also a bit of Mars, of course. We almost cannot do an episode without at least mentioning Mars, right? A new study utilizing the Trace Gas Orbiter, part of the ExoMars mission, found that surprisingly high amounts of water regularly go high up into Mars' atmosphere, with Mars' atmosphere actually becoming supersaturated with water at times. This means that Mars' upper atmosphere then contains 10 to 100 times more water vapor than normally should be the case. And then the sun's ultraviolet radiation breaks apart the water molecules into atoms, and then the solar wind pushes these atoms into space.
So that's the sad process of how Mars has been losing giant amounts of water in the last few billion years. And this process is unfortunately still very much ongoing, as we now know. So Elon, hurry up, we must get to Mars fast or else there won't be any water left. Just kidding, the process is still very slow to a human observer and only noticeable on timescales of millions of years. But of course we still hope that Elon will hurry up as much as he can. And hurrying up he always does, as we know, which we can currently see in Boca Chica again.
With insane record speed, SpaceX assembled a mini Starship tank that consisted of 2 domes and only 2 single-walled steel rings, the structure having served the purpose of a pressure test article. And it did serve this purpose very well, as Elon tweeted, having reached a burst pressure of 7.1 bar, with 6 bar being the minimum threshold necessary for an orbital test flight. He thinks that they will reach a burst pressure of 8.5 bars in the future, which is a factor of 1.4 above the safety requirement for crewed flight, significantly higher than the normal minimum requirement of 1.25. And of course, work on the Starship SN1 prototype is progressing further, with lots of parts having now been moved into the new tent, and assembly will probably begin quite soon.
So there's very fast progress indeed happening at SpaceX as always, and we'll keep you updated on the developments.
It's so cool that we can now really send LightSails to other star systems.
That's really amazing. And what do you think, when will we discover the first life on another exoplanet? This decade? Next decade?
Tell us in the comments. And we wish all the best to SpaceX for the upcoming Crew Dragon in-flight abort test.
We hope they will be successful, of course, and we cannot wait to see them finally launch astronauts to the ISS, right?
And if you want to help this channel to grow, please give this video a like or even share it with your friends. That would really mean a lot to us. So see you in the next episode.
See you!